Assalamu alaikum students. Today we have to read about the energy levels of hydrogen atom. We know the energy associated with the nth orbit of hydrogen atom is E equals to En, actually equals to minus 13.6 electron volt by n square. Where n is a variable and it's known as a principal column number. Its value is equal to 1, 2, 3, 4, 5, 6. Now if n is equal to 1, once n is equal to 1, that is electron in the hydrogen atom is in the innermost orbit, that is electron is in the innermost orbit of hydrogen atom, then E1 equals to minus 13.6 electron volt by 1 square. Instead of n we put 1, it is simply minus 13.6. This is the lowest energy, this is the minimum energy associated, minimum energy of hydrogen atom. And we can say and we can say that atom is in ground state. Ground state means when the electron in the hydrogen atom is in the innermost orbit, then it is having the minimum energy, that is minus 13.6 electron volt, because n is equal to only 1. And we can say that the atom is in the ground state. So what is ground state? Ground state is when the electron in hydrogen atom is in the innermost orbit. Now if n equals to 2, that is electron is in the second orbit, at that very time, then E2 equals to minus 13.6 electron volt divided by, instead of n now we are having 2 square, and it comes out to be minus 13.6 electron volt divided by 4, and it comes out to be minus 3.4 electron volt. So this is the energy associated. So it now the energy, listen one thing, the first energy was minus 13.6, now the energy is minus 3.4, so it becomes now less negative. Less negative means it's tending towards the positive value. Now the electron in the second orbit is not so much bound as it was in the first orbit, because in the first orbit we were having this very much energy, in the second orbit it is having this very much energy. So electron is not now so much bound towards the nucleus as it was in the first orbit. So this is called as first, this energy of n is equal to 2 orbits called first excited state. First excited state energy. And we can say that electron is in the excited state. When n is equal to 2, that is electron is revolving in the second orbit, then energy associated to this level is how much? Minus 13.4, which is called as first excited state energy of hydrogen atom, of H atom. Now if we are going to proceed like this, and we are going to say like this, if n equals to 3, then what we are having, E3 equals to minus 13.6 electron volt over 3 square, and 3 square comes out to be 9, and it is minus 13.6 electron volt by 9, and that comes out to be 1.51 electron volt. And this is called as this was called as the first excited state energy, this is called as second excited state energy. Why these are called as excited state? Because now the electron is not in the innermost orbit. Once the electron is in the innermost orbit where its energy minus 13.6 electron volt, then that is called as what? That is called as minimum energy of the hydrogen, and that is called as the ground state. Once it is in the second orbit, once it is in the third orbit, then that is called as the first excited state. For n is equal to 3, it is called as second excited state of hydrogen atom, so on and so. If we proceed like this, if we are having now, if n equals to infinity, but you have to here listen one, it is minus 1 point. Now listen, now the energy becomes less negative. First it was minus 13 point, now then it was minus 3.4, now it is minus 1 point. So now the energy of the electron in the orbit becomes less negative. By less negative, you have to understand, now the electron is not so much bound towards the nucleus. If now n is equal to infinity, then E infinity equals to minus 13.6 electron volt by infinity square, and that comes out to be 0. It simply means that electron is no more bound towards the nucleus. This energy corresponds to the highest energy level, which means that electron is completely free now. It is free from, now if the electron is in this free state, that means electron is free from attractive force of nucleus, hence is not bound to with the nucleus. Now if we are going to draw a diagram of these very energy levels, what we'll find, we'll find like this energy level of hydrogen atom. For, I will make it like this here in the paper. Okay, let me make this very much as one of the energy level. I will say it n equals to 1, which is called as now ground state. And what is its energy? Minus 13.6. This energy is in electron volt. Electron volt energy. Now this is the first energy level, n is equal to 1 minus. Now the second energy level, which is E is minus 13 point. Let me make it like this. N equals to 2, and it's having an energy of minus 3.4. It is now, from this, it is the first excited state. Then we're having, for n is equal to 3, we will have, if you are going to calculate at your home respectively, then you will find out the energy will be like this. N is equal to 3, and you will get an energy of minus 1.51. And if you are going to calculate it for n is equal to 4, it will be minus 0.85. If you will go to calculate for n is equal to 5, then the energy will be minus 0.54. Now if you will go to calculate for n is equal to 6, just listen how I am making the diagram. Just see towards it. Minus 0.38, and if you are going to proceed infinitely, then n is equal to infinity, and it equals simply 0. Now there is a huge gap between this and this, because for the first level, for the ground state, you are having energy of minus 13.6, and for the second state you are having a difference, energy of minus 3.4. But as you are going higher and higher, the energy levels are very much close, because there is now very small difference between the energy levels. So by plotting a diagram, once you have to show small difference, then you have to show they are a bit closer. So what we can conclude from it, it is clear from this very diagram that as principal quantum number increases, the energy states come closer and closer to each other because of successive decrease in the energy levels. Because अगर आप यहाँ और यहाँ पे difference, if you are going to check the difference between this and this, there will be a 10.2 difference. This and this, there will be very smaller. This and this very smaller. So we have to represent this, these very energy levels, the higher energy levels, as you are going higher. By higher I mean less negative. And for till the electron is within the initial, it is bound towards the nucleus. It shows this very diagram. But once the electron is the infinite shell, and it is free from any attractive force, then it is said to be as, it has now, there is no force of attraction between electron and, what I mean to say, and that is called as the ionization. till these very states, from this very point, these are called as excited states. Excited states. And this is energy level, energy level diagram of hydrogen atom. This you have to draw. It is very much important related to the examination point of view. So this is all for today. Tomorrow will be with another lecture. Till then, Allah Hafiz.